Hey there, M&M lovers. Who here can't get enough of those colorful little yummy chocolates? You know what I do before eating them? I like to sort them in groups based on their colors and count them. Like that. Here I have 2 orange, 3 blue, 3 more orange, 6 green, 2 more green, 10 red, and 1 blue. I will add 1 color at a time. I have 5 orange in total. And 4 blue, 8 green, and 10 red. What I did so far is addition. I grouped them by color, and I counted the chocolates of each type separately. Now if I give some to my little sister, my chocolates will be less. I will give her 4 green and 1 blue. So green ones, 8 minus 4. Now I have 4 left. And now blue, 4 minus 1, that's 3. As you can notice in this subtraction, I didn't need to write number 1 next to B to refer to 1 chocolate, because it is already clear that it is 1 since it is not any other number. So when the amount is 1, we don't write the 1. What we did here is subtraction. Let's try another one with mixed addition and subtraction. 2 brown, plus 1 red, minus 1 red, plus 2 green, plus 5 green, plus 10 yellow, minus 4 green, plus 11 brown. So brown is 2 plus 11, this is 13 brown. Red is 1 minus 1, so red is gone. Green is 2 plus 5, that's 7, minus 4, that's 3. And 10 yellow. I think to say 13 brown plus 3 green plus 10 yellow is much more simple than what we started with. So, the benefit of combining or grouping anything is to make it more simple. As you saw, when we combine our M&Ms, we combine the like ones together. They increase by addition and decrease by subtraction. That reminds me of our lesson today, combining like terms. Like terms are exactly like M&M, we can only add or subtract them if they are like each other. We add and subtract them to make our expression shorter and simpler. But how can we know that terms are like? Like terms are terms that have exactly the same pronumerals, with the same power. Again, like terms are terms that have exactly the same pronumerals, with the same power. So x can only be added to x. They are like terms, but it can't be added to y because they are unlike terms. And also, it can't be added to x squared because although it is the same pronumeral, but it has a different power. So they are unlike. Check these examples out. Ask yourself about each pair. Why is it like or unlike? As we said before, all what matters is the pronumerals to be the same and the power to be the same. But the coefficient, or in other words, the number that you see before the letter doesn't matter. It only tells us how many do we have of the term. For example, in the like column, the first one shows that we are combining 3 of x to 4 of x. We can combine them because their type is the same, which is x. In the second one, the type of both is y squared, while on the right side, the types are different. We see x and y, then w squared and v squared. Now it's your turn to check your understanding. Are these like or unlike? In the last one, we have a b and ba. I want you to know that the order doesn't matter. They are like terms. As we said before, all what matters is to have the same pronumerals with the same power. Now we move to the easiest part of combining like terms, which is adding and subtracting them. Remember our colorful M&Ms? We're going to do the same thing with our terms. Let's start with a simple example. 3x plus 4x. So the type of the term here is x and the type doesn't change, only the amount does. We have 3 of x and we are adding 4. Answer is 7x. Here is another one. 5k minus 2k. Again, k is the type and the type doesn't change. We just change the amount. So 5 minus 2, answer is 3k. 6b minus 8b. Did you notice that we are taking away a bigger number from a smaller number? The answer will be negative. Negative 2b. If you need a refresher, check out the link to the negative integers video. Now let's mix things up a bit with multiple types of terms. My golden advice to you here is to use highlighters. And every time you look at one type of terms, highlight it with a different color. And don't forget to include the addition or subtraction sign that appears before it. 3k plus 9b plus 2k minus 7b. This can be simplified by combining the like terms together. 3k plus 2k is 5k, and 9b minus 7b is 2b. Done. Another one, 5x plus 6y minus 9x plus 3. Same idea. 5x minus 9x is negative 4x. Then we only have one term with y, so we just write it, and one constant term, which is 3, we put it as well.
One more.
3 plus 2k plus 4m plus 2m minus k. 3 is the only constant term, so we write it. 2k minus k. This k is 1 as we said before, even if the 1 is invisible. So answer is k. Then 4m plus 2m is 6m. Now it's your turn. Pause the video and try to answer these questions, then check your answers. Let's finish by a worded problem. Ronnie and Octavius each work for n hours per week. Ronnie earns $25 per hour and Octavius earns $30 per hour. Write an expression for the amount Ronnie earns in 1 week, in dollars. Well, we know that Ronnie earns $25 per hour. That means if he works 1 hour, it's 25. If he works 2 hours, it becomes 50 as we multiply by 2. And if he works 10 hours, it goes up to 250 as we multiply by 10. So you can notice here that every time we multiply the hourly rate by the number of hours to calculate the total. But we don't know the number of hours. We just know that we refer to them by pronumeral n. No drama. We multiply 25 by n then. So Ronnie earns $25n. Second part, write an expression for the amount Octavius earns in 1 week, in dollars. Same idea, but this time the hourly rate is higher. It is 30. We still use multiplication. So Octavius earns 30n. Last part, write a simplified expression for the total amount Ronnie and Octavius earn in 1 week, in dollars. Easy. That is 25n plus 30n, which is $55n in total. So to recap, terms can be combined to simplify expressions. We combine terms by adding or subtracting them. This can only be done if they are like terms. Like terms have the same pronumeral with the same power. When combining like terms, we don't change the term type, we only change its amount. Great job, everyone.